theta function with the input data set. This one with this one. So this is the differences. The cost function in this case would be the mean of the sum of the square of these differences. Like for example, this one is formula. If we do the cost function for this example, the value now is equivalent to 0.58. Now clearly the cost function is higher than the previous case. In the previous case, the theta 1 is equal to 1. So this one is when theta is 0 equals to 1, and this one is when the theta is equal to 0.5. The cost function equation is simple. To find the parameters theta so that the cost function is minimum, so that the curve best fit the data. So when we plot, the curve will be like this. We must choose the parameter value where the cost function is minimum. In this case, where the cost function is 0.5, it is better compared to when the theta is equal to 1. This would give you the best possible fit to fit your data. Thank you.
Afika Azman, and I will explain about gradient descent. This figure show about the function of parameter and function of x, where the function of x is about the line of current hypothesis toward the training data, and training data at toward the center of plot is shown by this. The intuition behind this function, the contour plot represent the same value function with theta 0 and theta 1. If value of j function is equal to 1, the same value will be obtained at hypothesis function. The minimum value of rate occur at plot. The value theta is of the change function. The point of theta is located at the center. It reflects near with training data by showing at this hypothesis. By minimize the cost function, the linear function will be accurate. So in the learning rate, this is the for alpha too small. When alpha we choose in small, the convergence will be slow. While the alpha is too large, the increasing value of j theta will be occur with effect for overshoot at the minimum, and it also can cause a fall to converge. As we know that the effect of momentum is does not configure, which is the step size is depend on the momentum. Moreover, the momentum can take past gradient into account to smooth the step of the gradient descent. That's all for me. Thank you.
Hi, I'm Sabrina, and now I'll explain about logistic regression cost function, which is represented by these two equations. So we have two conditions. First, we have y equal to 1, and the second one is y equal to 0. So for the first condition, if y equal to 1, we will use this equation, and it will represent by this graph. So if hx equal to 1, the value of cost will be equal to 0. But notice that if hx approaches 0, the value of the cost will approach infinity. So therefore, we will penalize the learning algorithm by a very large cost. So next, if y equal to 0, we will use this equation, and it will represent this graph. So if the value of hx is equal to 0, the value of the cost will equal to 0. And notice that if the value of hx approaches 1, the value of the cost will approach to infinity. So therefore, it will capture the intuition that larger mistake should get larger penalties. So that's all from me. Thank you.
Hello, my name is Nina Armanila. I will explain about cost function with regularization. In this explanation, we'll have the example of linear regression and also intuition of cost function. First thing first, I will show the example of linear regression. This is the example of the price of the house. The first one is underfit. The curve for underfit will be drawn in the data. It's like a linear graph, and the equation will be theta 0 plus theta 1x. And the second one is just right, and the graph for just right will be like this kind of curve, and the equation will be theta 0 plus theta 1x plus with theta 2x square. And then for the third one is overfit. And for the overfit, the curve will pass through all the data set, and the curve will be not as good or as better or even as smooth as other two. And the equation will be fourth other polynomial of data. And then in order to overcome the not smoothness of the curve of the overfit, to use the cost function in order to get the better graph or better hypothesis. Then in order to get that, we need first we need to modify the objective. This equation is objective, and then we need to add plus 1000 theta 3 square plus 1000 theta 4 square. And then the new equation, we need to minimize its parameter. The parameter will be theta 3 and theta 4. In order to minimize the parameter, we need to equal the parameter with the smaller value, for example 0. Why we need to get the parameter into the smaller value is to get rid these two terms. The first term is this one, and the second term is this one. And then the quadratic will be this theta 0 plus theta 1x plus with theta 2x square. That means the two terms behind is not included, because since the parameter theta 3 and theta 4 is equal to 0. And then the quadratic will be this curve. This is the curve before, and then when we apply this, and then we can get this smoother curve. Thus the curve becomes smoother, and the hypothesis will also become better. That's all for my explanation. Thank you.